Hi everyone, it's nice to see you again, and today's lecture is about solving the questions of the section point 11. Exercises 1.1, we're going to find, let me write it, find domain and the range for the following function. Find the domain and range for the following functions. Function number 1 will be f of x equal to 1 plus x squared. As we studied in the previous lectures, we know that this function is a polynomial. So according to the notes, the domain of the polynomial f will be always all the real number because I have no restrictions. Now we're moving to find the range of this function. As we studied in the previous lectures, we found that the range of this function to be found, we need to change the formation of the function from the formation which is y equal to of x to the no presentation which is x equal to of y. Now I need to put the terms that contains x in the side and the other terms in the other side. So I need to move this one to this side and change its sign. So that will be y minus 1. And then I need to square. So I'm going to square both sides. X squared, square root. I need to apply the square root to the both sides. The result will be y minus 1. I need you to know that we have two things. I'm going to write it right here. We have two things. If we have a value squared and we apply the square root to it, the result will be the absolute value of that value inside the square root. And then we all know that, I assume we all know that the absolute value for x will be plus minus x. But if we have the square root to the value squared, the result will be just x without absolute value. So now, after we apply the square root to the function, I will put the result like square root to x equal to the square root to y minus 1. And after I open that or apply the square, apply the absolute value, I will put the plus minus, but I will move them to that side. So x equal to plus minus y minus 1. Now I found the new formation. This is the new formation, which is x equal to a function written in terms of y. Now, after I found the new formation, I need to find the domain to this form. So I will say the domain for the function x, for the new function, that will be, actually this is a square root functions, and to find the domain for a square root functions, I need to put a restrictions that the expression inside the square root must be greater than or equal 0. So I will tell, let me first solve and then I will construct the domain. So y minus 1, I will force it to be greater than or equal 0, and I'm gonna move the minus 1 to the other side. The result will be y greater than or equal 1. So this is the conditions that I need to satisfy to construct the domain of the function x. So the domain of the function x will be all the y in the real line that satisfies one condition, which is y should be greater than or equal 1, which is the resultant of the main function. So the final result that I'm gonna get is range the function y, which is the original function, will be y in the real line such that y should be greater than or equal 1. And we finished the solution to this function. I'm going to graph the function. He didn't ask us to graph the function after we finish finding the domain and the range, but I'm going to graph it just to make things consistent. It's a polynomial that's shifted with 1 unit up. Okay, so the graph will be, this is the polynomial y equal to 1 plus x squared. We can see now that the domain of the function, it's all r because I have no problem of substituting any real number in the polynomial. And we can see that the resultant or the results of the function, the output of the function, always greater than or equal unit 1. It's above the line y. See, this is the line y equal to 1, and all the results or all the output of the function is above the line y equal 1. Just to make it consistent, make things consistent to you. You don't need to plot. You need, if in the exam sheet, if the teacher asks you to find the domain and the range and they didn't tell you the graph, you don't have to find the graph. Just find the domain and the range. But I just graph to you just to make things consistent and to make it clear to you and to provide you with the full understanding of the concept. So, question number 2, f of x, this is function number 1. I'm gonna write it with another color. I hope it will be clear. 2, f of x equal to 1 minus the square root to the value x. First, I'm going to classify the function and put it in its class that we studied in the last 3 lectures. I can tell now that this function is a square root function. So to find the domain of this function, the problem is very easy. I need to construct the expression inside the square root to be greater than or equal 0. So it's too easy, just straightforward. So I'm going to put the domain of the function f. Okay, I can call it y, no problem, because I know that f of x equals y equal to same thing. So I can say the domain of the function y, okay, all x belongs to real line such that x greater than or equal 0. Just I'm going back here just to clarify something. We can write, I need another color just to make things distinguish. Most of the calculus teachers write the domain of the function f or the domain of the function y. As I told you, this is same thing if I write it 1 or plus x squared. So we can write just the domain of the function f or the domain of the function that way, minus infinity, which is same thing or the same notation for the real line. So I can write it as this expression as a constructions for the set of the range or the set of the domain, or I can write it as an interval, the same thing. So here we can write the domain of the function y as this expression or as this representation, or I can just write this as interval. So I can tell now that the 0 is included because there is equality in here, and all the numbers, it's not good infinity here. I have to, yeah, see? Why? Because I understand from this construction that x greater than 0, and it's absolutely and logically, intuitively, that it's less than infinity. Okay, so I'm going to choose whatever I want from these. They are both right. Okay, so you can choose in your time, in your exam sheet, any expression of these expressions. So now the problem, or the next step, I want to find the range to this function. To find the range, as we studied, as we know, to this function, which is y equal to 1 minus, I need to change the formation. So I'm going to change, to move the square root of x to this side, will change its sign, and I will keep 1 minus 1 minus y here. Now I'm going to find the x. I have two paths, two approaches to solve here. I can construct it from here, and I can understand right now that as soon as it's a square root, and a square root cannot be negative, the result of a square root cannot be negative, I can now tell that y. So I'm going to tell you a hint. When I say domain, I need the conditions or the constructions of the elements x, the input. When I say I want to find the range, I need the constructions and the conditions that bounded or construct the elements y, which is the output. So here I can find the instructions, I can see them, so I don't have to complete the solution. I don't have to go to simplify this expression more to find the constructions of the element y, which is the inputs. No, I can say as soon as the square root of x is always positive or 0, I can say that y minus 1 minus y greater than or equal 0. So y should be always less than or equal 1, and which is this one, right? I can find the range from here. So the range, so the domain to the new function, I'm going to call it x, because x is same thing. I mean the square root of x is same thing. I mean by x not just to make it this x. Yeah, I mean by x the new expression. Okay, so when I say domain of the function x, I mean the new expression. So I'm going y belongs to the real line such that y less than or equal 1. Okay, this is approach 1. Approach 1. Let me call it approach 1. Approach 1. Path 1. Okay. The other path, a student said, no, I'm going to find x, so I'm going to square. So I'm going to square both sides. I'm going to get x squared equal to, going to square this expression. So the square root to x squared equal to 1 minus y all squared. What I'm going to get right now, I'm going to get x equal to 1 minus y all squared. Okay, so to find the y has no restrictions. So I'm going to say that y domain of the new function x, according to these simplifications, according to the last expression, should be r. The domain of the function x should be r. That means the range of the original function, which is y, should be r. And we can see from the graph, and with the enough experience that you should get through your solving the exercises and studying the subject, you will see that this is wrong. Why? Because we cannot get a number more than 1. Because if I want to graph this function, the graph of this function will be as follows. The maximum value is when x equals 0. When x equals 0, when I substitute 0 here, the result of y will be 1. And when I substitute 1 here, the result will be 0. It's a curve. See? When I substitute 4, so minus 2 plus 1 minus 1. So the result will be that way. this is the maximum value, which is y equal 1. This is the maximum value, and the resultant or the output of this function is always less than y, less than 1, which is y, and equal to 1. So always the output y is less than or equal 1. So it cannot be the range or the output of the function is all r. So how we can solve this problem? Why did we get this output? We did this output by squaring this term, because if we square this term, we will add a new half of the real line, which is the negative half. And in reality, we don't need to square here. And if you wanted to square, you have to observe, because most of the questions cannot be re-represented. For example, I don't want to go deep in this subject too much, because I don't want to go more than it should be. But just to make things clear to you, because I'm sure that there is a lot of tutorials about the domain and range of the functions, but in this course I'm trying to give something new, or to give something special. So if we have a polynomial, for example, of the degree 3, imagine that we have a plus x3, a plus x4. To change the formation of this polynomial to the other expressions, and if you want to try to put a polynomial of degree 3 or a polynomial of degree more than 2 in the other expression, which is x in terms of y's, it will be almost impossible, very, very hard. So we usually use the symbolic programs like Mathematica, Maple, to change the formation for us, because it's too hard and time consuming. Here I want you to understand that I don't want you to be just a machine trying to follow the notations and solve the question. I want you to observe that finding the domain is just to find the constructions to the input elements, and find the range is just the constructions to the output elements. So whenever you find something helps you to construct or to put boundaries to these constructions, you just stop and choose them. You don't have to follow all the notations and just move them, go or follow them blindly. So we don't need this. But if you want to solve, if you want to complete and try to find the solution, you need to observe. So as you observe, you can just delete the negative half, or the negative half of the real line. So I'm going to erase this, because we don't need it right now, because we already solved the question. Okay, so I just try to predict what the student could do wrong and get a wrong output, a wrong result. So now I'm going to say that the range of the original function, which is y, equals to y in the real line such y is less than or, okay. So I'm going to plot it here. I'm going to do the plot here. The plot will be the maximum value here, and we can see this y equal to 1 minus, and this is y equal to 1, which is, we call it the upper bound of the function, because there is no value for the function more than that y. So we called it sometimes in calculus and in mathematical analysis, we called it the upper bound of the function. It's not the upper bound, it's called the supremum, or the, okay, don't bother. I think it's enough for today, and I hope I will see you again in the next lecture and solving the next 4 questions. We have 4 more questions. See you guys.